Here in question number 12, a metal block of heat capacity 100 joule per degree Celsius placed in a room at 30 degrees Celsius is heated electrically. The heater is switched off when the temperature reaches 40 degrees Celsius. The temperature of block rises at the rate of 2 degrees Celsius per second just after the heater is on and falls at the rate of 0.3 degrees Celsius per second after the heater is switched off. What was the rate of change of temperature of the block when it was at 35 degrees Celsius? Two different situations that actually being mentioned clearly, that is, at initial situation when the object is having the same temperature as the temperature of the surrounding itself, at that time the rate at which the temperature was changing, it was 2 degrees Celsius per second. So I would say P is the power of the heater and it is supplying the heat energy with the rate of dq by dt. So this must be affecting in change of the temperature itself. So how much we shall write here? dq, it must be written down as c into dt. So this will be the value of dt here. Fine. So I would say dq by dt will simply be c dt by dt. How much is the value of c? This is 100 and the change in temperature is 2. So we are getting the power to be equal to 200 watt for the heater. Another situation now, when the heater was switched off at the time when this body had just attained the temperature of 40 degrees Celsius and the surrounding temperature being 30 degrees Celsius. So because of that temperature difference, the heat will be lost and that will be depending upon the difference of the temperature here. So dq by dt, in fact it shall be written down as k, temperature difference being how much? It was 40 30 here with the negative sign. Okay, so dq will now be taken as dq by dt will be taken as c dt by dt. This time the change in temperature is actually negative. So I would say c being 100, change in temperature is negative, so this is 3 by 10. I will just omit this value negative sign because of the reason I just mentioned here. It will be k into 10. So this 10 will cancel out and we are getting the value of k to be equal to 3 for the case where the heat will be lost because of convection and radiation itself. So altogether the total heat that will be going into the system at any time, it will be because of the power supply there and because of the loss by the radiation and convection. So I would say P minus H. In fact this is the value of H I'm writing here. So how much this value is? It is 200 and the value of H, it was 3 and this time it is T minus 30 degrees Celsius. So we need to evaluate the rate of change of temperature. That means the dq by dt at the time will be, it is 200 and the temperature being 35, so this will be 15 and it must be taken as c dt by dt. So it is 185 divided by 100 is actually the rate of change of temperature at that time. So the value of 1.85 degrees Celsius per second is the correct answer for question number 12. Option C is the correct answer actually. So let's proceed now to question number 13. Here in question number 13, a sound wave takes time t1 to travel the distance L if air temperature is T1 and takes T2 time if air temperature is T2. If the temperature of air changes from T1 to T2 linearly over the distance L, then time taken T0 in terms of T1 and T2 would be. Let's say this distance is L here and the temperature at this end being T1 and here it is T2. So definitely the temperature at any particular distance x can be written down as T would be equal to T1 plus T2 minus T1 divided by L into x, or I would say this term can be taken as T is equal to T1 plus mx. M shall have the value of T2 minus T1 divided by L. Now it's been given that when the temperature was T1, at that time the velocity would be V1 would be equal to how much? Ct1. So for that case, the time T1 should have been written down as L divided by root under Ct1. Similarly, for the case V2, when it will have the temperature T2, then time T2 should have been written down as square root of here Ct2. Now, if the temperature changes from T1 to T2 linearly, then the total time taken by the wave to travel this much of the distance. From this equation, I would say velocity v would be taken as square root of Ct. Fine, I'll solve this equation here. So look, it will be written down as dx by dt here, should be taken as c, and it is T1 plus mx, or it is dx divided by square root of T1 plus mx would be square root of c dt. Integrate this part with proper limit. I will be getting 2 square root of T1 plus mx here with proper limit. This m will come in the denominator, so it will be appearing in this side. It is square root of c into m into T0 to T0, and it is from 0 to L. So from this equation I'll be getting 2. Putting the value of x to be L, I shall have this answer as square root of T2, and putting the value of x to be 0, I'll be getting this answer as square root of T1. So from this side, m was how much? It was T2 minus T1 into L, and here square root of c, that must be taken as T0. So this portion, it would be T0 to L, square root of T2 minus square root of T1, and here T2 minus T1. Definitely I will have square root of c here, square root of T2 plus square root of T1. Multiplying this factor, square root of Ct2 shall have the value of L divided by T2. That means now I would be saying it will be 2L here, and it is L divided by T2 plus L divided by T1, or finally it is 2 divided by 1 by T1 plus 1 by T2. So I'm getting option B as the correct answer for question number 13. Here in question number 14, a metal wire of length 1 meter fixed at both ends is clamped in middle by using a bridge. Both the parts vibrate in fundamental mode with frequency 200 Hz. Now the bridge is displaced by distance delta x such that both the parts oscillate in their respective fundamental mode with frequency differing by 4 Hz. Value of delta x is. We shall be taking this delta x to be very small, so we may use some methods of approximation here. Anyway, let's have the situation first. This is the way the string was actually vibrating initially, frequency being 200 Hz, and the length of this wire is 1 meter, so this must be 1 by 2 meter from here to here. So how much is the wavelength, by the way? This will be lambda by 2. It will be 1 by 2, so I would say lambda is equal to 1 meter, or wave velocity will be 200 into 1, that will be 200 meter per second. Now fundamental frequency of this part will be f is equal to v divided by 2. Length of this part now it is 1 by 2 plus delta x. Similarly, the fundamental frequency for the other part, it will be v divided by 2 L by 2 minus delta x. Have this calculation, find the difference of these two parts. I'll be saying f1 is equal to v divided by 1 plus 2 delta x, and here f2 is equal to v divided by 1 minus 2 delta x. Okay, so the difference was f2 minus f1, it was 4 Hz. So clearly v divided by 1 minus 2 delta x minus 1 by 1 plus 2 delta x must be equal to 4 Hz, or delta f is equal to 4 Hz. It is coming out to be v. Here it is 1 plus 2 delta x minus 1 plus 2 delta x, and it is 1 minus 4 delta x square. We just said the delta x is very much small as compared to this one, so this portion will be neglected. So what we are getting here as 4 is equal to, this v was how much? It was 200. So here it is 4 delta x divided by 1. This 4 will cancel out, and we are getting delta x is equal to 1 by 200 in meter. So in centimeter it will be 1 by 2 centimeters. So for question number 14 we are getting option A as the correct answer. Now let's proceed to question number 15. In question number 15, figure shows a plank of mass m on which another block of mass m by 4 is attached to a pole on plank through a spring of force constant K. All the surfaces mentioned are smooth. The block executes simple harmonic motion when displaced from mean position. If maximum velocity of block during SHM is 2 meter per second, then amplitude of motion of plank is, well, the value of K, that is actually being given as 20 Newton per meter, and m is equal to 4 kg. The composite system will execute the simple harmonic motion with the angular frequency, I would say, omega is equal to square root of K divided by m reduced. How much is the value of m reduced this time? 1 by m reduced will be 1 by capital M plus here 4 by capital M, or effectively it is 5 by capital M. So the value of omega would be square root of K. M reduced is capital M divided by 5. It will be 5 here. So putting the values 5 into 20 divided by 4, we are getting the value of omega to be 5 per second. Now maximum velocity of the block during the SHM is 2 meter per second. So the amplitude of the vibration of the block would be A1 into omega, that has to be taken as the velocity. So A1 this much into omega 5 will be taken as velocity, that is 2. So the amplitude of the vibration is coming out to be 2 by 5 in meter for the block here. So what about the amplitude of vibration of the plank? So let it is A2. So I would say A2 into mass m must be as A1 into m by 4. This is from the concept of center of mass shifting. So this one will cancel out. We are getting A2 to be equal to A1 divided by 4, that is 2 divided by 5 into 4. This is in meter, so actually it is 1 divided by 10 meter. So we are getting A2 to be equal to 0.10 meter. So for question number 15 we are getting option B as the correct answer. Let's now proceed to question number 16.